Hello everyone, this is the GATE topic quantum mechanics, and today we will talk about GATE 2009 question paper, and the question number is 7. Which one of the functions given below represents the bound state eigenfunction of the operator minus d2 dx2 in the region 0 to infinity with the eigenvalue minus 4? And there are 4 options. So there are two things we have to remember. One is like, you can see this is says that it is a bound state eigenfunction, and the after operating this operator minus d2 dx2, the eigenvalue should be minus 4. So first of all we need to check which one among these four, which one is the bound state eigenfunction. So let me first check about a0 e to the power 2x. So this is not a bound state. Why? Because when x equals to 0, it is giving us a0, that is finite, and this is fine, no problem. But if I take x equals to infinity, then our a0 e to the power 2x is giving us an infinite value. But infinite value is not feasible. That means at x equals to plus minus infinity, our wave function should be 0. So, a0 e to the power 2x is no longer a bound state eigenfunction. So, we will not check the second step for this case. Okay. Now, coming to C option. In the C option case, you can see a0 e to the power minus 2x. So, if I put x equals to plus minus infinity, like let's say as it is given that 0 to infinity x range is there, so we will not talk about minus infinity. So we will talk only about x equals to plus infinity. So if x equals to infinity, then it will go as e to the power minus infinity, so which is equals to 0. Okay. So now this wave function will have a 0 value at x equals to infinity, and x equals to 0, it at this point the wave function has a finite value which is a0, that is fine. So now the first condition which should be satisfied, that bound state eigenfunction, the C is the one which is the bound state eigenfunction. Now coming to the second condition, that minus d2 dx2, if I apply on this wave function, the eigenfunction value should be minus 4. So let me check that. So minus d2 dx2 a0 e to the power minus 2x. So if I just calculate here ddx, then a0, then it will be like e to the power minus 2x and then minus 2. Okay. Now minus again ddx. Okay. So it will be like a0, then plus 4 will be there, minus 2 and then e to the power minus 2x. So it will be minus 4 into a0 e to the power minus 2x. So we can see that the minus 4 is the eigenvalue for this eigenfunction a0 e to the power minus 2x, and the eigenoperator is minus d2 dx2. So for this case, all the two conditions whatever they are wanted is satisfied for the option number C. So the correct option will be option number C.